Okay, thanks, Matt. So this talk is about the open source desktop Anaconda distribution. How many people have Anaconda installed in their desktops? Okay, great. For how many of you is it working? Okay, maybe I should have asked which one, who doesn't have it working? Okay. So it's good that we have it installed and it's functional. And for the next 50 minutes, I'm going to give you just a little tour of how to use the distribution, how to get the most out of it. We're going to talk about the packages that are installed with the distribution, how I can access my data that I have access to from my desktops. How can I install other packages? Where do I find these packages? What packages do I need to install? And that's going to be our goal for the next 50 minutes. So as Matt says, I am a data science instructor. I go around the country to our customers and I teach Anaconda. Mostly I teach the open source Anaconda distribution. And a few of our customers who have the enterprise platform, we teach it on the platform. So I came to Python through Fortran. I spent a lot of my time on theoretical chemistry and supercomputing and was really just enjoyed working with Python. I no longer had to fear about strings. I could talk about data. I could talk about big, high-level concepts. I didn't have to worry about syntax. So the first thing we want to do today is make sure we install Anaconda. So if you haven't done it so far and you want to give it a try, go ahead and install it. You'll notice here that I've got a GitHub link if you'd like to download the notebooks and code I'm going to be working with today. I'll give you a second to pick that up. This is going to be on every slide. So while you're downloading this stuff, I'm just going to yak for a few more minutes here. So data science is complicated, right? We don't even know what it means. Are people like me, scientific computing professionals, are we data scientists? Or are people who do machine learning and statistics data scientists? What sort of side you take on this little spectrum here doesn't really matter, but a good data scientist needs to be able to use these kinds of tools. You need to be able to get to your data on big systems, make some good web-based presentations, or just grab data from the web. We need to do our tabular data, Excel-like things. And we need to start thinking about machine learning and statistics. So there are dozens or hundreds or thousands of packages that people like to use to do these kinds of things. And they come in a number of languages. So you can see here that things like scientific computing are based in Fortran and C and C++. Down here on the web portion, we need to worry about JavaScript and Java. And up here, we can worry about Excel and SQL. So it's complex because there's a lot of things you can do. People come from different backgrounds. It's complex because there's a number of different nice packages. And it's even worse that all of these packages are written in a different language. And so how do you choose? Which one should I really spend my time on? And the goal here of Anaconda is that really Python is a great glue language between all of these fields. And we'll see a few examples of these kinds of things that we're going to be able to think of Python as the center of our data science ecosystem. We want to be able to find a way in Python to leverage a really fast Fortran code. We want to find a way to deliver and serve a web API or a nice plot. We don't ever have to open Excel ever again in Python. We can just read the data right off the Excel sheet. And we're going to connect to our C++ libraries for doing things like machine learning or, say, TensorFlow and deep learning. This is our goal. And to make that really possible, we use Anaconda so that we have one place, one thing we download to get to all of these packages, all of this complexity. So the thing we're talking about today is called the Anaconda Distribution. Always free and open source, where we're going to have access to are 1,000 or more curated packages for doing all of those components of data science. Whether it's developing code or making plots, doing our machine learning and our AI, and connecting to our data. And this is going to just work on Mac, Linux, and Windows. So if you've downloaded Anaconda, you've got right now 200 or so packages pre-installed. The same packages for Mac, Linux, and Windows. And so it doesn't matter what systems we're using. We're going to be able to do the same thing, write the same code, and use the same libraries. OK. So with that in mind, I might as well give you a live demo. And the goal here is that we want to say in Python, there's a package for that. If I want to access Hadoop Hive tables, there's a package for doing that. And the way I think about it is if I can imagine something I want to do in Python, like search through a text file for things that look like addresses, there's a package for that. It may not be in those 200 or so packages, but today we're going to learn about how to install other packages from out on the web. And the tool we're going to spend most of our time with, just to get started with the distribution, if I can get my thing to work, OK, it's called the Anaconda Navigator. So if you've got Anaconda installed, you should be able to find the Anaconda Navigator either for the Windows Start menu or using Spotlight on your Mac. It may appear in your /applications. And we should be able to find our way to that. And so let's get started with our little demo. I'm going to just sort of have a quick overview of how we get to Anaconda, open up our notebooks and do some of our code and connect to our data. So if you've got then the GitHub that you can download here, this is where we're going to access our data in our notebooks. Matt will walk around a little bit. If you're having some trouble, raise your hand and he can help you out. So I've got Anaconda installed, and I can go find that tool called Navigator. I've installed Anaconda 5.1, and actually, I'm sorry about that. Let me get the screen mirrored correctly. There we go. That's better. So I can find my Anaconda Navigator either with Spotlight or from the Start menu. You should see a folder called Anaconda 3 or 2, depending on which version you've downloaded. So Anaconda Navigator is going to be our interface to the whole Anaconda distribution, the whole Python ecosystem, where we're going to be able to do our work. So just right here on the front page, you'll see tools where we're going to be able to write code, interact with our data. I'm going to launch the Jupyter Notebook. This is my favorite tool for doing Python data science and interactive data exploration. It comes pre-installed. Jupyter runs in your web browser. It's not opening up a public port. It's just opening up a little private port for you to use on your desktop. Here I have a nice little file browser where I can go find all of my Python code. And so I downloaded that GitHub link to my desktop. So you should be able to eventually find, say, the Anaconda Distribution IPYNB. So this is not a .py file. An IPYNB is called a Jupyter Notebook. It's a rich sort of document where I will have code, some text descriptions, output, plots, interactive plots, all sorts of interesting web-based things. So if I launch then my Anaconda distribution, let's take a little tour of some packages we might use to get to our data. So as I said, Python is a glue language. For all the buzzwords and all the special things people like to talk about, with Python. It's not Python itself that does SQL access or reading from the web. It's a package written for the Python ecosystem. The Python language is really very simple. It defines sort of just enough complexity for people to be able to write these really special tools. Even better, these tools are written in different languages. Right? We know for certain the scikit-learn has some C++. NumPy is going to have some Fortran code buried way deep in there. And we're using Python to sort of bring everything together using a minimal amount of, say, overlapping class types, just to make certain that everything sort of plays well together. But we're going to be able to work with a bunch of different kinds of objects. And so for this notebook here, we're going to make use of requests, which is our HTTP access out to the web to be able to connect with a website and download data. We're going to download HTML files, and I like to use the tool Beautiful Soup to get rid of all the junky HTML things and get at the data I really want. We're going to have data out on an SQL table, in this case just an SQLite file. And the star tools here are NumPy and Pandas. These are our fast data processing and tabular data access tools. And from there, we'll be able to make plots and connect to our machine learning. And a little preview for later is these are not the only packages that do this stuff. So the first thing I think about in my Python is let's import somebody else's code. We're going to import requests and Beautiful Soup, SQL Alchemy, NumPy, machine learning, and Pandas. So in the notebook here, if I select the cell and I press Shift-Enter, that cell gets executed. So what I really want to do is model literacy and fertility. And I've got data all over the place. I've got data here in Wikipedia, or I've got a table of literacy for males and females around the world from UNESCO. I don't want to sit there and copy in those values cell by cell, say into a file or to an Excel sheet. I should be able to use Python to just go get the data. And a little Google search comes up with the package called requests, where I can make a request to the website, snag it in. This is pre-installed in Anaconda. I now have the HTML read into memory, and I can use the tool Beautiful Soup to go work through that and make for myself a nice Python container. And so now the third tool I'm using is Pandas to make this convenient-looking table where I can now work with my tabular data in sort of the same ways you do with SQL. You can do pivot tables and group bys. You can be confident that you're working with numeric data very fast because that's written in C in a low level. So for one example, I might grab all the countries where the female literacy was greater than the male literacy and sort that and grab the top 5 countries. And we see that Cuba is at the top of this list. So the goal here with the Anaconda distribution is to reuse these packages to access your data and to do your data processing. And the first thing you think about is there a package for that? So if I have data in an SQL table, how do I get to it? There should be a package for that. That's called SQL Alchemy, where I can just provide the path or the host name to that SQL table, perform my query right on the table, and get a subset of that data back. Here I'm returning it back as a Pandas data frame. I'm using Pandas as my internal representation of my data from a dozen different sources. I had to work a little bit harder to get that Wikipedia table into this Pandas data frame rows and columns. For things like SQL or Hive tables or CSV files or Excel sheets or SAS, that's automatic. You don't have to think about things line by line. You can compose whole expressions to say, take this Gapminder data set, which has multiple years, filter out only the 2013 data and those columns that I'm interested in. So this is the goal of the ecosystem. Now that I've got my data in compatible formats, I can merge it all together. I've got now fertility and literacy in my data frame. You can do useful statistics with the pandas package, or if you really wanted to do, say, like ANOVA tests, you'd find some other package to download and install. The better packages use these pandas data frames or NumPy arrays as their default representation. Finally, I can make my linear regression, inspect, say how well did this data fit. All of this is using scikit-learn. And in the end, make my plot with matplotlib. So in something like maybe 50 lines or so, I was able to grab data directly off of Wikipedia, process it down a little bit, grab more data from SQL, merge those two things together, make my linear regression prediction model, and display the results. All of this is done right here in the Jupyter Notebook. I can interact with my data and interact with its representation. I can save this notebook and give it to other people. If they're using Anaconda, if they have access to the data, they're going to be able to work with it in the same way. And so all of the data that I've used here is in that GitHub link. You can take it, practice with it for yourself. And all this works because the Anaconda distribution has these packages pre-downloaded. So we'll spend time talking about what these packages are. But if you click on the Environments tab within your Anaconda Navigator, you'll see a long list of packages that we've curated. These are packages that we at Anaconda test to make certain that those versions are compatible, that they do what they say they're going to do. So you can be confident that when you download Anaconda, these things are going to work for you. But these 200 or so packages are not all you want to do. They're just common. We could have tried to zip up, say, 1,000 packages, but that makes the download file much bigger, a little bit clunkier to work with. So we want to be able to add new packages to our Anaconda. So I'm going to flip back to the presentation here. So package management in Python is a hard thing. How many people have really messed up Python before by installing packages? Right. Messed up. Even, this would be sort of okay if it only took you 5 times, right? And then it actually worked. Sometimes it takes 5 tries and then nothing ever works again, right? This is the problem. This is the traditional problem in Python. So Anaconda doesn't just give you 200 or so packages that we say should be sufficient for all your needs. We give you a tool to add and remove packages from your environment called Conda. So this is our Conda package manager where you can safely install, remove, and update packages. You don't have to think about editing files or your site packages or your Python path. This is all controlled by the Conda package manager. And further, pip does this, but Conda does it to a much better extent. We want to automatically install dependencies that work. This is the real magic of Conda. If I want to install 5 packages, I don't need 5 packages. I probably need 50 because each of them have 10 dependencies. Conda's job is to go figure out what those dependencies are and install the correct compatible versions. You'd say, that's pretty nice. Conda doesn't do that only for Python, but for any other kind of language, because Conda just ships relocatable package binaries. So we also don't even need compilers. That's somebody else's job. Whether that's the Anaconda developers who, say, take this really great package they found on pip, they prepare the package for you, they compile it, and make sure it's going to work on Mac, Linux, and Windows. And then once you want to download them, we'll be able to go out to this Anaconda repository that we maintain out on the web and download, say, some of the 1,000 or more packages that we've already created for you. But there's probably like 10 or 100,000 packages that you might want to really have access to. And so we can use packages that are created by other people in the community, Conda Forge being the leader on this. So that somebody developed something just yesterday, you might actually find it on Conda Forge. That's independent of us here at Anaconda. We work with them closely, but they are community-driven, no sort of financial or business ties to Anaconda. Right? So what about the case where somebody gives me code that's in a different version of Python, Python 2 or Python 3? How do I maintain, say, different versions of NumPy? So we'll cover today what's called the Conda Environment. And the way I think about this is, how can I maintain separate Python installations with arbitrarily different package versions? We're going to, similar to a virtual env, we're going to make separate Conda environments where we can independently and safely upgrade, download, and remove packages without interfering with any other environment. Think of it like separate Python installations. I want to have an installation for Python 2 to be able to work with some old code. I want an experimental installation where I can just download some of the latest things. Or if somebody gives me some code and I don't know how they built it, I need to be able to start from scratch and investigate. How does this package work? What are the real requirements? And we're going to be able to do this, again, directly from Anaconda Navigator. So let's see that in action. This is what I call reproducible data science. So here's our Anaconda Navigator. Instead of using the Jupyter Notebook, I've installed Visual Studio Code. This is now my favorite source code editor. You can install Spider or use any other IDE you want, but we'll find that VS Code has some really great features when you use it with the Anaconda distribution. So I'm going to launch VS Code. It's from Microsoft. So we have a partnership with Microsoft to be able to provide this direct from the Anaconda distribution. So along with that notebook we ran earlier, I have a little script file just called script.py. Let me see if I can zoom in. There we go. So I have a little script here. It does a little bit of NumPy. And so when you launch Visual Studio Code, you should see that it's actually using the Anaconda Python 3.6, because I just downloaded Anaconda 5.1. I get Anaconda 3.6. And now if you're paying close attention, something's wrong with this code. Let's try to run it. So I can right-click and run the file right here in the VS Code in the terminal. And it says, oh, crap, something's wrong here. Something is going on here. And I say, oh, wait a minute. This doesn't look like Python 3 code. Somebody gave me this file and said, this is really good. You should use it. But I can't right now. I don't have my environment configured correctly for how they intended me to run this code. But luckily, they gave me a little note up here that they developed this with NumPy 2.7, or Python 2.7 and NumPy 1.10. It's unlikely to work in any other version. So let's see if we can use Anaconda to mimic their environment. I'm going to turn off VS Code for a second. So what I need to do over here in my environments is just sort of ignore this thing we call the base environment, those 200 packages that were pre-downloaded and installed. I want to go create a new environment, a sandbox, or a test environment, completely separate of this to go work with this code. So I'm going to create a new environment. And here I get to choose Python 3 or 2. I could also install R, again, completely separate from Python. So I'm going to call this old. Doesn't really matter what name you give it. So it's going to go out to the Anaconda repository, what we call Anaconda Cloud, download Python 2.7 and just enough packages to make it work. So we'll give that a second. So now I've got 16 packages. All I wanted was Python 2.7, but that's not quite enough. I need a few other things. Conda does that automatically. Not only do I need Python 2.7, I need NumPy. So you notice here that this little toggle here says installed. If you flip it to not installed, there's our 1,000 or more curated packages on what we call the full Anaconda distribution. We downloaded only a subset. And so now I want to be able to search for NumPy. And just in the search box, I can go find NumPy or other related NumPy-ish packages. And if you look closely here, that's not the right version. I need version 1.10. The interface is a little strange, but if you right-click on the box, we can now go and select a particular version that we wanted. And I'm going to go find the latest in the 1.10 series. So I right-click on that little box next to the name of the package, and I can pick any version I want. So I'm going to pick 1.10.4. So it says here, one package selected, NumPy. Great. Let's get it in there. I don't only need NumPy, I need a BLAST library, a matrix library, that Fortran code I was talking about. That's called the math kernel library. Conda knows that's a dependent package. It will automatically go and grab it at the latest compatible version. So not only do I need NumPy, I need my BLAST matrix library. And I can go apply and install that. So now I've got my environment set up. I'm going to turn this back to installed, clear this off. Now I have 18 packages. It looks like I'm ready to go. So I'm going to turn back on VS Code. Doesn't really matter sort of which of these environments you have sort of viewed at the time. VS Code is going to give me an interface to select between these environments. It likes to automatically update to new versions, so you'll get this pretty frequently. I'm going to open my script again. Yeah. So when I launch a PY file, remember that VS Code can work with almost any programming language. I can click down here in this Anaconda, and I can now go and choose a different Conda environment that I created from Anaconda Navigator. I want to use that old version of NumPy in Python. And I know that it's correct because it tells me this is now Python 2.7 down there. And so I can right-click anywhere in the file, run the file in the terminal. I no longer get the error, but I find that 64 is that midpoint in that NumPy array of numbers. I'm now able to use this older code. It uses an old API of NumPy, which would allow you to select with floating points. So if I had this at 2.0, my code still works. Okay, so VS Code and Anaconda Distribution, particularly Anaconda Navigator, give you a great way to install packages, keep them up to date, and be able to flip between these environments. So you don't have to stress out about how do I install something and, oh crap, I got to uninstall Anaconda just to be able to use some old Python code that somebody wants me to use. Okay, but we're not quite done with all of this yet. Back here on the environments. So I downloaded Anaconda 5.1. That's been out a couple of weeks. I'd say within the next month or two, there's going to be an Anaconda 5.2. But now what do I do? I've already got my environments created. I've been working with it for quite a while. I don't have to uninstall Anaconda and install the new version. I can use Navigator to keep myself up to date. So notice, some of these packages are blue. There's a little blue arrow up there. There's a little blue arrow, say, in this package called Bokeh, our plotting tool. That means there's an update available. Every time you launch Anaconda Navigator, it's going to go out to Anaconda Cloud, our repository, and check what are the latest versions, and identify that maybe you want to think about updating that. You don't have to. And so I can mark this for update. Again, I need to right-click on this little checkbox. I could mark for update or choose a specific version I wish to install. I'm going to mark Bokeh for update. I'm going to go find Dask. And let's mark that one too. So I've marked 2 packages. Let's apply. Sometimes it takes a little while, but I don't only need those 2 packages. I need to update a few other things. Conda, the package management system, will behind the scenes go figure out that in order to maintain compatibility so that these packages just work, you've got to update all these other things too. And we'll just let that do exactly what it wants. Did I press the wrong button? And we'll apply. Seems to be not doing that, but that's OK. So I have a way of keeping my packages up to date. Let's see, if you come all the way up top, let's see, Anaconda's not here. All right, that's a different thing. So it's good every once in a while, if you want to keep, say, this root environment up to date, to just kind of scroll through and see what's new, whether you really want to use it. Personally, I hardly ever touch what we call this base environment. Because when I want to start a new line of development, I think first, am I going to use Python 2 or Python 3? So if I want to go again, I'm going to create a new environment, this time at Python 3. I'm going to think, OK, what do I need to do in my environment now? Maybe I need to access SQL tables. Maybe I need to access web data. So we'll give that a second to complete. Every time I start a new environment, I'm going to get the latest versions of these packages, unless I tell it otherwise. So for me, it's a better idea to leave something like the base alone and to leave many of these environments alone rather than pick one and continually update it. Because then it's a little bit extra work, and I forget what version I was using at a particular time. So every project I run, I think about first making a new Conda environment. So on my general system, I have something like 30 or 40 of these things. Maybe every 6 months I clean them out and say, I'm not working on that anymore, I don't need it. So there's my new environment. We know that on the Not Installed pull-down menu, I can access these 1,500 or so packages. But that's, in some sense, not a lot of packages. New Python packages are being created all the time, being added in to do one little special thing. So we want to be able to access a wider range of packages. And these are what we call channels. So I'm going to go add a new channel. Right now it's called defaults. This is the 1,500 curated packages, vetted, tested by Anaconda. The next important set of packages is called Conda Forge. So here if I add Conda-Forge, I'm going to have access to another set of 4,000 more packages. Where I can now get a set of packages developed and maintained by the community. The good thing about Conda Forge is that they are tested, they are vetted in some way, and there'll be packages for Mac, Linux, and Windows, at least where appropriate. If you add other channels, you may not have as much sort of peace of mind that somebody spent some time thinking about this and that these things are actually working. So the two important channels are the defaults, the Anaconda repository and Conda Forge. So now I have access to something like 4,700 packages, where if I want something fun, say, I can search for pandas, and I can find all sorts of different kinds of pandas things, like this thing called Pandas ML is an extension to scikit-learn to do more pandas-like model development. Rather, scikit-learn is itself developed more for NumPy. So if I just want to install Pandas ML, which comes from the Conda Forge channel, I not only need pandas, but I'm going to need everything else. I'm going to need my math kernel libraries and NumPy. And all the other packages that the developer said you need to have installed. So that'll take a few more minutes, and I'm not going to sit and wait for that. So back to the presentation. If you Conda install a Python library, feel confident that it's going to work. If it doesn't really work, maybe send us a note, and we'll try to help you out. There's a lot of support on Stack Overflow, Stack Exchange, and on the GitHub issue trackers. But how do I know that I'm using the package I want to use? So the quote that I have here is that there's a lot of Python packages because you want to find a Python package that does the one thing you're interested in really well. And this is the philosophy of Unix that I think works really well in Python and is highly adopted. Is that if I want to think about doing modeling, I have a number of packages to pick from. They may formally do the same thing. I can do a linear regression in each of these three packages. But if I want to do it at the lowest level, I'll use SciPy. If I want to feel like I can feel more like R and look at my p-values and look at my confidence intervals, I'll use stats models. If I want to go do things like cross-validation and what I call the mechanics of machine learning and think about deploying my model in production, I'll use scikit-learn. And I know that because I went out to the web and did a little Google search. How do I do a linear regression? I came back with 3 packages. Now I have to make a choice. And it's a good habit to try to explore your choices. And how do I make good choices? And the way I think about it is not does it have the feature that I want, but how do I use it? So it matters to me how it's used. There are Python packages that return sort of pure Python objects like lists and dictionaries. And there are Python packages that play really well with vectorized codes, NumPy and pandas. And depending on what I want to do, most of the time I want to do tabular-like data, vectorized processing. I want to find a package that has good support for these things, so I don't have to try to wrap things like dictionaries and lists back into mine. So that's the first thing I think about, is how do I use it? What are the objects? What other packages does it interface with? Then I might say, well, is one package faster than another? Does it work really well on larger data sets? And the final thing I think about is, if I want to keep using this package, does it feel like it's going to be updated continually? Some packages don't get a lot of attention, and you want to be very careful if you're using a package that doesn't get updated very frequently. Things like NumPy and pandas, they'll move fast. And these packages may break really quickly if they're not also maintained. And the final question is, where do I find it? We saw that the defaults channel has something like 1,500 packages that we've tested and vetted. Conda Forge is a good community channel where you can submit requests for packages to be added, sort of track issues. And if you absolutely must, go ahead and pip install. You'll pip install directly in your Conda environments, and you won't have to worry about messing up other systems. So if I make a new Conda environment and pip install 5 packages and the 6th package breaks everything, I haven't messed up Anaconda. I can remove that environment or create a new one and try again. You should feel safe really hacking at your environment and just installing exactly what you need when you need it. For those of you who are thinking about enterprise-like use cases, you can track down one of our sales reps about Anaconda support, where we can help you support some of these open source packages that are available in the defaults channel. All right. So with that, we're getting a little close on time here. So how do we go on from here? I've just highlighted a couple of talks here that I've sort of trolled through the schedule for. If you want to learn more about Conda, how it works, why it works, how to make even better use of it, go see Kale's talk tomorrow at 10. I've got a talk tomorrow where I'm going to try to connect to every possible data source in one notebook. Merge data from every source I can imagine, SQL, SAS, Hadoop, Hive tables, data from the web, all using Matt's tool called Dask. Tomorrow at 1 o'clock. And say over in the real world, you might find another data talk interesting, and how Anaconda can help you get to your data, because it's got all the packages you need. All right. So with that, that's the end of my talk. If you were having trouble, say, downloading and using Anaconda, come see me after, and we'll see if we can help you out a little bit.